Okay, let's proceed to the next topic, which is step response for the RC and RL circuit. So let's start with the step response for RC circuit. Okay, so we have here step response of an RC circuit. Okay, so the rationale for this one is that we have a capacitor.
So the rationale for this type of uh, circuit or calculation is that our capacitor um, possibly may have an initial charge, or also it can have a zero charge as the initial value, or initial voltage as zero. Okay. So this also means that the behavior of your capacitor would be on the possibly a charging or discharging depending on the voltage that you are supplying to your capacitor. Okay, later we will explain it more. No, what does it mean to be charging or discharging? Okay, so first we have this type of circuit where we have um, our the voltage supply and the resistor and one capacitor. Okay. So this is the model of our RC circuit in its very basic form. Okay. One capacitor, one resistor, and one voltage source. Okay. So how do we solve this kind of circuit? First, we can do is that we will use KVL. Okay. KVL right here. So KVL. Okay, loop one can be right here. Okay. Much better if we follow the current of the direction of the current in our capacitor. So we will be doing clockwise. So we have this IC. We have negative VS plus RIC plus VC. Okay. Take note, KVL is the system of voltages. So all of these are voltage. Okay. Next, we will be solving this in terms of the capacitor voltage, since the capacitor voltage is continuous. Okay, so we will be converting everything into a voltage. So we have here Vs. We can um, we call this uh, transpose. Transpose ba? Bali na to siya dito sa after sa equation. Okay. Then we have here an IC. We will need to convert it into a voltage. So how do we convert that into voltage? IC is equal to CdVc dt plus Vc is equal to negative Vs. Right there we have the first order differential equation. We will be dividing it by RC, 1 over RC, so dVc over dt plus Vc over RC is equal to, okay, this one should be already, okay, ibalin naman natin. So, mawala ng yung negative becomes positive Vs over RC. And then, we will do variable separable. Variable separable dVc is equal to negative Vc minus Vs over RC. Okay. dVc, okay, combine the common terms. Vc minus Vs is equal to negative Vt over RC. And then we need to integrate both sides. This one in terms of V at 0 time, V at time, and this one from 0 time to T. So, there. And then integrate them. Integrate. So what will happen is that this one becomes ln of Vc evaluated from V0 to V of T is equal to negative T over RC 0 to T. There. ln of P of T minus Vs minus ln of VO minus Vs is equal to negative P over RC. Combine the ln, since we have a minus right here, we can do the division. P of T minus Ps over Ps0 minus Ps equal to negative P over RC. Then we can do exponential on both sides. ln will be cancelled out. V of P minus Vs over x0 minus Vs e to the negative P over RC. Next, we can cross multiply V of t is equal minus Vs is equal to V VO V0 minus Vs over e to the negative t over RC. V of t is equal to Vs plus V at 0 minus Vs e to the negative t over RC. But we all know, class, that it's not always that the switching starts at 0. So we're just going to convert the V at 0 into VO so that this can be applicable to any time frame where the switching has occurred. Okay? Vs plus VO minus Vs e to the negative t over RC. Okay, so this is your voltage for all time t or at t greater than TO or t greater than 0. Okay, the next step, class, is we're going to compute this same circuit based on the book. The book has solved this one using KCL. Okay. Method 2, based on KCL. I'm going to show you two analysis of this one now. So based on the book, we have this. We have here IC. We have here IR. Okay, this one is because we have PL right here. And since we follow this one, so it would mean, uh, but this one is based on the book. Okay? So we will just be following this one. Okay, KCL at node A. Okay, we will do two analysis so that it's not too confusing. Okay, so based on the book, we have this KCL at node A. Then IC plus IR is equal to 0. Okay, IC, we will be solving it based on the voltage, capacitor voltage, and we know IC is equal to CdV dt, CdVC dt, plus IR. IR here is based on the two voltages, VC minus Vs divided by the R is equal to 0. So yeah, this one is actually just the same equation that we got earlier. So we divide it by 1 over C. We have dVC dt plus VC minus Vs over RC equal to 0. We will be doing variable separable. dVC dt is equal to negative VC minus Vs over RC. Variable separable, dVC over VC minus Vs is equal to negative dt over RC. So based on our previous calculation earlier, we will get V of t is equal to Vs plus VO minus VS e to the negative d over RC. Okay, another method is that another one is we will do a KCL at node A, but we will do this one. ABC, we have IC and IR. This R, this one is VS. Okay. So we will have IC minus IR equal to 0. So IC is CdV CdT minus IR will be instead of VC minus VS, we will do VS minus VC over R equal to 0. So there we will have to um, supply the negative to VS and VC. CdVC dt plus VC minus VS VC minus VS over R equal to 0. So they are the same. Okay, they are the same right here. Let's simplify now. VC dt plus VC minus VS over RC equal to 0. So now they are both the same. Okay, that's another method. Okay. How about let's do the current. We'll be doing current. Anyway, how do we solve for the current? Okay. Let's use this one, the KCL. Solving for current. So we have here negative VS, convert it over there, and then transfer it right here. So we have RIC plus VC equal to 0. We convert our VC into current. Ay, not 0. We have here VS. Okay. Next, RIC plus VC is equal to 1 over C integral of IC dt. Equal to VS. Now we have an integral, we need to differentiate d over dt. Now this becomes R VIC dt plus derivative and integral is cancelled out. We get 1 over c DIC. Derivative of constant is 0. So, next, simplify, multiply 1 over r DIC over dt plus, oops, sorry. Okay. IC over RC equal to 0. So you may notice, class, this is the equation for our current, and this is similar to the per source free RC circuit, where the value of this becomes I of t is equal to I O e to the negative t over RC. Okay. So why do we get this kind of value? No, it's because um our current is discontinuous. Okay. So uh, when we have a switching, our current um, is not like the voltage of the capacitor. Our current is discontinuous. So we only get the natural response of the current when solving for a step response of the RC circuit. And then we will have last method, which is this one. We will copy this. This one. Okay. This one is called the complete response. Complete response, we get P of t is equal to V infinity plus VO minus V infinity e to the negative t over RC. Okay, this one is your VSS or steady state. And this one is your transient response. Transient, okay? Response. Because if you're going to graph this one, let's say your VO is lesser than your VS, meaning mas gamay ni siya value, like sa to 10 volts, sample, 10 volts is greater than 20 volts. Okay, so meaning your initial values step response will be like this. Okay. We get 10 volts, and then let's draw red. Your VC will increase up to 20 volts, and then padayon din siya into a steady state. Okay. Okay. This one This one is your transient response. So let's call this TR, transient response. And this one right here is the steady state. Steady state. Take note class na si capacitor achieves steady state due to the fact that if there's no changing current, if there's no changing voltage, diba, IC is equal to CdV/dt, there's no changing voltage, capacitor becomes open. So, once there's no changing voltage, mo na ning iyang steady state. It will be constantly 20 volts on an open capacitor. Okay, so what happens if we get this kind of state? Like VO is greater than VS. Example, we have ano to, 15 volts is greater than 10 volts. Okay, ang imong gisupply sa iya ha is smaller sa iyang initial value. Unsa siya? It will be a decay. This one is charging. This one, you will get a discharging na transient response. Get a 15, this one is 10. Okay, from here, we get discharging and then we'll maintain that one. This one is your transient response. And this one will be your steady state. Okay. So, this right here, na siya nahitabo na discharging of 5 volts. So, we can actually do another method now. V of t is equal to V transient plus V steady state. This is your what we call complete response. Complete response.